What I want to say is that we can create things also with limited amount of money, not necessarily big things, small things that impact on a huge population. So we again believe, and many people are convinced, that they have to focus on a big reality, big city with tens of millions. If we want to do a smart city, this is the scenario. But really, again, I have the impression that probably, apart from these 88 big cities, we have to focus on cities that are much smaller, because the statistics say that most of the cities are around 100,000, so under 50,000, something like the city Messina. Okay, so we are lucky because we live in a city of this sort of dimension. So, according to the previous forecast that were completely wrong, I propose to focus our attention in a much smaller environment, that are the majority. And in that case, I think it's much easier to address lots of problems that are related also with the management, with the administration, with the municipality, with all the things that are around us. And sometimes this represents a big limitation. When you want to do something and you have to have so many authorizations, you have to have so many tables to meet and to talk with people, that becomes almost impossible. And this forecast, I think, is not only in Italy, but the same is United States, India, Japan, China. Most of the cities, most of the people live in small cities of around 100,000 people. Okay, so we want to focus on the city. We believe that small is better, and this is the target that we have in our mind. Okay, so smart city, more or less, we focus and understand what we have in our mind. Then we want to create services. We want to connect people. We want to try to improve the life condition that these people have. We want to use, as with Altair, we want to use the intelligence of single people that may also contribute with their work, with their brightness, to create devices, to create services. So something that starts from the bottom. So I'm thinking about the makers movement. There are 100,000 people all around the world that meet periodically in many parts of the world, where they share ideas, where they share solutions, where they discuss, they build on their own the single device. And we know that if we think with the IoT, for example, Arduino is one example of this community. Simple device that is used by millions of people all over the world. They create and they use this device for the most strange and incredible services that they have in their mind. And of course, the idea is to work and do this all together, to use open approach. That means open software. Okay, I think is the direction to go. Open data. If we generate data in a big city, this data should be open. And this is also certified by the Italian government that recently said that the municipality, they have to make open or most of the data. And similar things also in other European countries. I also believe about open hardware, similar to what we do with software, hardware that is open. Arduino is open. The design are available. You can download, if you are able, you are in the condition to do that, you can build your own Arduino. And the aspects are quite evident. Millions of people are using this technology, are making experience and learning how to use and program this device. So the idea of smart something, smart city, is not new, but it is very popular in the last years. As for example, you can see here from some Google Trends, and we see that in the last 2-3 years, the requests related with the smart cities and services increased a lot. Why? Because this is related, I believe, to the fact that at the same time there is the investment from the public sector. There are money coming from the government, central government, local government, that decide to invest in this scenario. And also private companies, Cisco and others, they have a big support program with millions of euros, and they try to identify some place where good ideas are, and they try to invest also in this technology. So money are a good driving effect, and necessarily we need the public money because in any case the investment may be complex, And to start, you need some input, so public-private relations, and then you have to create something that attracts the interest of small, medium enterprise, people living around, that on the underground framework that is created can help in developing new services. What I see is that ICT is in any case a sort of unifying glue, because whatever we try to develop that may be related to mobility, to energy, to infrastructure, ICT is there. You need programming, informatics, communication. These are the basic technologies that nowadays are as a sort of fundamental element, whatever you have in mind, whatever you want to create. So I think that ICT is the heart of a smart city. Because if you want to simplify, it's a sort of control system where you have to acquire information from the environment. You have sensors that give you an idea of what is happening, and of course this data are to be collected, maybe in a cloud environment, yes. And then you need some algorithms that implement some data analytics, AI. So you have to analyze this data, to discover what they are saying. You transform the data into knowledge. This problem is related with big data. No? The big problem to analyze it is huge, incredibly huge amount of data that are generated every day. Every day in the world, we generate the equivalent of 3 Italian National Central Libraries that is in Florence. Every day, okay? With our pictures, with our movie, with our messages, and all of this. It's an incredible amount of data. So we need some technology that help us to understand what these data are saying. And once I understand this data, I have to simulate the evolution of my system and understand what is the direction that it is taking, and probably also to act with some action. So we have the feedback, where you collect the data, decide what to do, and then there is, through actuators, the action that you put in your real system. Okay, so ICT is important, and here we have many students for informatics, computer engineering, that are trying to learn and understand how to play with this technology. So the main problem now can be reconverted in integration of cyber part with physical part. So the Internet of Things is a huge amount of devices that are distributed all around. We have to control them, to interact with them, to collect the data, to actuate action, and so on. In the vision that I tried to describe before, of this smart city, that to me is a very interesting experimental field. It's a living lab. It is the name. Living lab is an environment where you have the basic technologies, you have the API, you have the software, you have the device. It's a sort of generalization of the lab that they were describing before in the previous presentation, much larger, where you can also offer services and at the same time give access, controlled, limited, whatever you want, to the device and the technology, to external parties that may be interested in providing, testing new technology. And I will tell you more about this very soon. So, smart city, it's an interesting lab because many different kind of technologies are there. Of course, technologies related with the monitoring of building, construction, bridge, tunnel, and things like that. But energy is another useful and strategic area, mobility and transportation. So, in a city you have different areas of action, and very often they don't talk each other. Some more advanced cities, they have already some infrastructure and they have some services there. But very likely these services are named silos, like vertical solutions that provide the services, maybe in a good way, but they do not communicate with each other. This is a big limitation. Because usually in this environment, the sum of 1 plus 1 is not 2, it's more, it's greater than 2. So if you are able to integrate, what you obtain is 1 order of magnitude higher than the simple sum of the separate contribution. So the general model, a defined clear model where you monitor, model, predict, action to manage your system. And this is the general organization. Of course, cloud computing is an interesting technology that you may use. We all use cloud, if we are aware, if we are not, but most of the services nowadays we are playing with are based on cloud solutions. So transparency, somehow unlimited amount of resources, there may be networking, computation, storage, and we are aware of that. So cloud computing platform is very likely the environment where the data are generated, stored, processed, and there are many possibilities. We decided to go with OpenStack. Why? For some historical reason, because we, in the last 10, 12 years, we took part to several European projects, and for some, I don't know exactly reason, we were always involved with OpenStack, and specifically our research group was asked to create the infrastructure, to prepare the environment with the different partners, then to make the experiment. So we learned what is OpenStack, how it is organized, how to install, how to control, how to use OpenStack. So for us it was quite normal. It is important, it's an open project, it's open source. You can download, you can use, it's there. So you are not related to any license, to any provider, to any company. It's completely open. And for a municipality, this is very interesting because they are not linked to any provider. OpenStack is organized in different components, different modules, and mainly it develops solutions related with the computation, with the networking, with the storage. So they have all the mechanism to play and organize the computing resources, the storage, and create a network between different of these objects. What we think is that the IoT part was missing. So we devote lots of time to add a new component, that is the IoT component that we named Stack for Things. There is an extension, an evolution of the OpenStack framework, fully integrated with OpenStack, that brings the objects inside the framework. So with this extended framework, now we are able to use cloud computing mechanism and process and approach, not only to computation and storage, but also to the I/O part. So we can dialogue, we can include sensors, actuators inside the infrastructure. For us, the object is not only a generator of data, it is also a generator of data, but it is part of the infrastructure. And we have to manage in the same way we manage in a transparent way computing and storage. So the traditional approach is that you have these devices distributed and they generate data. These data somehow are stored inside the cloud, and then there are different processes that access to this data, and they try to analyze it, to do whatever they are planning to do. This is the traditional approach. It's okay. Most of the solutions, all of the solutions are based on this kind of technique. That to me has some limitation. The main limitation is that when you're playing with IoT, very often you have to take fast decisions, real-time decisions. So as soon as the data is generated, you have to understand what is happening there and to promptly react. It is not always the case that the data can travel from the remote objects into the cloud, then is processed, and then you send the information back. Sometimes this is not enough. For sure you can do this, you have to do that when you want to analyze. You have data analytics, so you have big amount of data, you try to understand the trend, and you have time to do that. But most of the services, they want real-time reply. So this approach is not okay. In some cases, you have some limited access to devices if the producer gives you the API. So you can control the device a little bit, trying to specialize, adapt to some of your requirements. But it is not so common. What we believe is that we have to go for this solution, where the object, the IoT world, is inside the cloud. It's part of the infrastructure. And this is what Stack for Things is providing. The objects generate data, but not only. If they also have some computational capability as some kind of smart object, Then we can implement edge computing, fog computing. We move part of the computation directly on this single device. So you can try to answer the real-time requirements that I was saying before, using the computational capability of these objects and directly analyze and take a decision without having to wait for the data that reaches the cloud, is processed, and then back to you. So this is the approach that we are adopting. Edge computing, I believe, is a very important paradigm where lots can be done in the near future. So the intelligence is not only centralized like in the cloud, but it's already moved as much as possible to the edge of your system. The Stack for Things architecture is based on some elementary mechanism, but very powerful, so that this is the representation of a generic object. When I say object, it's something that can also have some intelligence on board. So I am talking about devices such as Raspberry Pi, Arduino, STM Nucleo. This kind of simple device that the makers movement use a lot, very cheap, but with interesting computing capability and connectivity. They use several kind of protocols to be connected with the external world. So these devices are associated to a physical device, are part of the physical device. And we have some code to be installed on this device that is named Lightning Rod that create communication channel with the IoTronic service, which is the extension to OpenStack that has been created. So you install OpenStack, you have IoTronic, and when the board is open and it is connected to the electricity and it's wake up, it immediately try to contact this service using a protocol that is named BUMP. This is the belonging to the family of the WebSocket. And we use this protocol because working at the HTTP level, we can go through firewall, we can go through NAT, and this is okay, because in a smart city you have 1,000, 10,000 of devices. They are connected to many different local area networks. And you have to go through NAT and firewall, otherwise you cannot connect with this device. And you cannot have any idea of where these objects are connected previously, because you have not the control of the local area network of this building or that building. Okay? So BUMP is very important. Once this first channel is created, then we use a reverse tunneling mechanism where we embed the role of the client and the server. So the device becomes the server that generates information that are sent to the client, that sent on the cloud. In this way, we are able to talk with all the devices, wherever they are connected, wherever is the distance, without any problems, without having to deal with complicated networking aspects. And I think this is a very interesting feature. So we can go a little bit more in detail, but I will not spend too much time. We have a channel for control information. Then other channels are created for the real exchange of data or injection of code, because we can inject code to this device, adapting and specializing their behavior depending on the specific requirements that we have. And everything is integrated inside OpenStack. So we use the OpenStack philosophy. You don't need to change anything. There are just new services that has been adopted. We use the Horizon dashboard for the graphical representation of the interface. We use Neutron for working at the virtual level of the networks. And this is very important because we are able to create virtual networks between some of these objects, some of the devices, that is specialized to solve a given problem. When these things are done, we can reconfigure the network, create new connectivity, use different numbers of sensors, actuators, computers, and storage, and prepare the environment to deliver new services. All this is done by software. So we can create this virtual connection. We can create a virtual sensor. A virtual sensor that is a piece of code running somewhere, and if it is the case, we can also migrate this code from one machine to another. But this piece of code is fed with the real data generated by physical sensors distributed around. So it's a virtual device that receives real data from sensors distributed in Messina, Rome, New York, and whatever, and it implements some logic, okay? Okay, this is the maximum level of abstraction, and it is possible with this device. So, software then is the glue between all of this. This is why we introduced the term of software-defined city. So, environment, big lab, with with the use of software, you can control, adapt, specialize, deliver services. I think this is really important. This figure represents a sort of abstraction, a representation of our system, where we have the physical part, we have the boards where you can execute some logic. They are practically some Linux device, a Linux machine. You have the representation or the virtualization of this board inside the cloud, so they are part of your infrastructure, and you can control, pilot, inject code, receive data, process, create virtual networks, whatever you want with this environment to optimize and control your physical environment. So open software is the basis of our action. Open data, of course, are extremely important, and open hardware where it is possible. Arduino is open hardware, a new device that we have recently developed. It is named Arancino. I don't know if you tried this Sicilian typical street food. It's the name of this new device that we created, and it is based, Giovanni will give you more details, on Arduino microcontroller and Raspberry Pi on the other side for the microprocessor. So in one single board you have these two elements, so you can easily interact with the external world, and you can have lots of logic running on the same machine. Okay. This project that is named SmartMe was started about 2 years and 2 years and a half ago. It started like crowdfunding initiatives. So we asked some money on the internet for publicizing our ideas to create a living lab inside the city. And we were able to start the process, and it went quite well because we collected about 3 times than what we were originally asking. We asked for 15,000 euro, and we collected 34 plus some extra donation that arrives later on. So it's of course interesting, but what is more interesting is the creation of a sort of community starting from the bottom. Community made of some students, some researchers, some small and medium enterprise, some big companies, one also from the United States, some public administration like the municipality and others. At different levels, they put some money, and we started. We started this project that had the idea to create an environment, an Internet of Things environment, where some kind of services were provided to the municipality. A living lab, because it is open, where if you want, you can make experiments, you can add the components, you can test and verify. And we developed some services. But these services were developed by us, and not only by us, because one thing also, a side effect, very interesting, is the interest that was raised by these initiatives. And several companies, not only local, actually, most not local, contacted us, and they said, I do these things. Can we talk and check if it is possible to integrate our solution with your environment? And we did that with many of them. So we have parking, smart parking solution, lighting, and so on. All services that show how, using an open source approach, you can try to integrate different solutions that share the same framework. The same framework, the stack for things, allow the immediate interaction between these services that otherwise are separated silos. Okay? The classic example that we have is smart parking solution and smart lighting. You control the lights in the street, the different lamps, you can switch on, switch off, and dimmer. We need one line of code to include, insert a new logic that say that if the parking lot is full also, then switch off half of the lights. For us, it's one line of code. If it is not like this, probably you will never succeed in doing that. Because there is one company with a closed solution that manages the parking, maybe very well, another one with the lights, and they don't talk to each other. So there is no way to create services like this. So this is the approach. The approach was further extended. A company was also created. It is a spin-off company of the university that is named ME.io, that today hire about 10, 12 people working there. Most are former students, others are people working there. So it's something that is coming, is working, is progressing. And the different services that we made as a prototype are related with environmental control, so some weather stations that are based on low-cost hardware, Arduino, Raspberry Pi, that are distributed around the city, and they monitor temperature, humidity, noise, quality of the air, some of these parameters. Fleet management, control of cars and buses, pothole detection. There is a crowdsourcing solution where we simply use the mobile phone of the students or the people moving and going around in the city, and they are able to identify the pothole in the street. Smart lighting that was done with a private company that today is installing about 20,000 lamps in the Milano area. Smart traffic lights was an experiment with the Telecom Italia, and so on. Many examples where the basic principle that I'm trying to quickly introduce here has been adopted, and we demonstrate that things can be done, are working. So these are examples of the weather station, indoor, outdoor. This is example of the bus. So you don't find it on the bus in Messina, although there were 25 buses that were equipped with that. But for some reason they decided to switch. We are cooperating with some other company like Share2Go in Milan and Bologna, where they have car sharing cars, and we are using these things. So with other companies that produce a big truck, where they want to monitor how the truck is used and where it goes, how it moves. Energy management. If you go downstairs, there are some offices that are equipped with devices that are able to monitor the use of the energy of the environment, so lighting, air conditioning, the electricity used by the device, printers, computers, and they are also able to manage the standby condition, so that if I don't use this device, after some time the red lights will start, but it's still using energy, between 7 to 10 bucks. If you multiply in place like this with all the computers and devices around, it's a big saving. If you implement a solution that is able to physically cut the energy when it is not used. When people enter the room, the system recognizes, and you start listening. So things switch on again, and when I sit in my desk, everything is running again. So it's an example of how technology can be used for providing energy saving, environmental respect, and so on. These are the devices installed around. Mobile crowd sensing is the application for pothole detection. So it's an app running on your device. When you go around and there is a sudden variation of the acceleration on the zeta axis, the system reports this information, associating this with the latitude and longitude. If there are many inputs from the same physical location, there is an algorithm that combines everything and concludes maybe that there is a pothole there, and can also give you an idea of the size, because it depends on the variation of the acceleration. And with the cost equal to 0, you can monitor your environment. Of course, there are some colleagues of us in civil engineering that say, okay, but it is not precise. We have a very sophisticated devices. They go around with a truck and with some cars behind with camera and very complex things, and they are able to detect perfectly how the asphalt is. That's good, but this is very expensive, and you cannot do it every day. So with this environment, the idea was you have an indication. Then if you want, you can take your car, go there and make very precise measures. But at least you are informed, the municipality is informed, citizens are aware of this. So it's an example where the citizen can contribute also with data to the overall system. Okay, this is a service that we developed in this museum. Practically the same environment was to monitor humidity, temperature in this museum in Palermo. Smart lighting developed with another company that is named Meridional Impianti, and they have their own solution. Through a Raspberry Pi device, we created a gateway that is a sort of interface between structural things on one side and their solution on the other. So their system is part of our environment and we can immediately control as if it is locally and natively inserted inside our system. This is an experiment done with Telecom Italia regarding smart traffic lights. It's something big as a room where there are objects like the cars, objects that are the traffic lights, and there is interaction, automatic and autonomous interaction between these objects. So when the car is arriving, it informs that it's arriving, and the traffic lights may analyze and take decision to say, okay, let's anticipate the green. So when it arrives, it's there. Evolution of this, for example, is that you can also interact with the lights. So not only you listen to the noise of the ambulance that is coming, but maybe the lights in the street start flashing. So if you don't listen, you can see. So different subsystems that you can combine and integrate to provide advanced service. This is a solution of smart parking, always with the Meridional Impianti, where the sensors are something that is put on the ground. They generate electrical magnetic field. If the car is put on top of that, there is a modification and they understand. So at the end, it's 1 or 0. With another company, we have another solution made with camera. So the object, in this case, is a camera that real-time analyzes the video, and frame by frame is able to count the number of cars there. So no physical installation apart the camera. With the camera you can cover an area of about between 10 to 15 cars, and again 1 or 0. So one or the other solution, you can see these things on the portal because they are living, running things. Then you have an app where you are driving, you decide where you want to go, you are notified about the parking lots in the area and the number of available space. You decide where to go, the system drives you, and then you can pay and so on. These things are like prototype here in Messina, but there are other cities where we already sold things and there are real services provided to the citizens. So in general, another area where we're working is with the camera and the real-time analysis of the image to identify objects. Examples are, for example, the parking, but for security reasons, you can identify an area, maybe a square, and be notified automatically if there is an unusual number of people in the street. Or if it is an area that is close to traffic, if there is a car, you are immediately notified. So you have to identify the objects in the system. So these things can be used, for example, in airport. The Catania airport has some implementation of these things to monitor some area inside the station. The municipality of Milan asked us to monitor some complex cross, where they want to be aware of the number of cars that pass through this cross in a time frame, and how many of them enter from this and take this direction or this direction, and so on. And they want to distinguish between car, truck, tram, and bicycle. Okay? So this is another possible application. This one is maybe more obvious, more traditional, but using Arduino, it was quite simple to create a device with sensor from Microelectronics that is able to monitor distance. This device can be put on the trash can, and it tells you the fulfillment status of the trash can. So if it is empty, maybe you with the car don't need to go there because it's empty. So every morning you try to organize and to plan the optimal path, so you reduce the gas usage, traffic, and you really go where it is required. This is another project that we are developing. In this case, the problem is to monitor last light. And this is done with some devices that are called inclinometers. And practically you have to make a pipe, a drill in the ground. I mean, it's a pipe between 20 to 30 meters length. And then inside of this, there is a chain of simple accelerometer that costs about €1, maybe less each. There's actually the one that you have in your mobile phone. You put the chain at this device, every 50 centimeters there is one with 3 legs, and you enter. When there is a pressure, the pipe will be deformed a little bit, and the movement of the scintillometer will tell us that something is happening, and the expert will be immediately notified. Okay? At the moment, the way in which these things are done, there is a guy that in the morning goes on the site. Sometimes they are located very difficult place, and they put this chain pipe by pipe, collect the data, and then goes back to the lab. Okay? So completely different approach. This is something I cannot say too much about that. Somehow inspired, related to the disaster that we had in Genova in August, where part of this bridge completely collapsed and 43 people died. So we are using Stack for Teams and all the related framework to monitor infrastructure like this. There are at the moment 2 galleries in A1 monitored with 1,000 of sensors, and a bridge, I don't remember exactly where. Some big companies are involved in this, and I cannot say too much because I am not allowed to say too much, but this is the general idea. Sensors that are distributed around and give you a feeling about the status of your building or your bridge. You compare every year in Italy there are about 3,000 earthquakes. Most of them are very little entities, so we don't really realize. But instruments, they do. So you characterize the building with an earthquake of a given intensity. Then, when new earthquake like this repeats, you compare the original behavior with the new one. Experts, civil engineers, are able to understand when things are becoming critical, and you can send alarms to that. So the strategy at the moment, and there are about some hundreds of houses being monitored, is to install these sensors in the pipe of the elevator, because the building is something that crosses the building from ground zero to whatever. So you can put these sensors very easily, because it's already open, just half a day of installation time. And then you start collecting this data. These data are collected with our software tools, and then they are transferred into IBM device, where there are some experts that are able to understand some artificial intelligence algorithms that are able to understand this data and what is happening. Okay. Carpooling is another initiative that we started. It was granted by G7 Transport in 2017. Okay. Conclusion is that many ideas, many service prototype, but what is very important is to have a common platform on the bottom that provides all the mechanisms to integrate the different services, and to have a uniform way to control and manage these devices. CINI stands for Italian Consortium Nationwide on Informatics. It puts together all the Italian universities. It is organized in 7 labs. One of these is Smart City and Community. I am, from this July, the director of this laboratory. And at the moment there are 31 participants, 31 university labs that with an overall number of about 400 researchers working on that. What we're trying to do is to have some initiatives to involve students in different parts of Italy with some sort of competition. I also asked some students of our master course if they want to join and to take part of this. And they try to learn this technology, they try to make some practice, they try to exchange experience and information, so they know each other. This is one initiative. Another one is to involve some schools, mainly high-level school, the fourth year of the high-level school, where we deliver some lectures involving the students of the school, where we give them a sort of simple box where there is a device with some resistance, resistors, LED, little electrical engine, and they are driven to make a set of experiments and experience between 10 to 15, and they start learning how to play with this. The results are really surprising. Students and young people that never did anything related with electronics or programming that start doing very amazing things. And this is something that we are trying to do all over Italy in different schools. We will start with the Turin, with about 10 schools involved there. And we have already experienced in the area of the Boston area where we did that a couple of years ago with the Italian consulate there. Okay, so facts, just summarizing what I have been discussing. Here you have some reference. Thank you very much for your attention.
Thank you to the speaker, thank you Antonio, and I forgot before to ask you if you have any question for the speaker, just 5 minutes, a couple of questions. And if you have a question for the previous speaker, please ask them by email or try to contact them even after the event. They are more or less available here. So, is there any question? Specific? So if there are no questions, we can go through the schedule. The next speaker, thank you once more time, Antonio. And the next speaker is Alexander Kapitonov from ITMO. I don't remember ITMO. You will say exactly what does it mean, but it's St. Petersburg in Russia university. And also, in this case, also from IRA.life, that is a company, a startup company he founded a couple of years ago, if I am not wrong, and it's also an interesting story. One of these, this success story that you usually read in magazine, newspaper, in order to encourage people to invest on IoT. So the stage is for you, Alexander, and thank you for your speech, for your talk today.